for a model boat is that it's not self-starting, it's just like the first high pressure cylinder. This is a cylinder mounting plate, and I'm showing here how the holes are put in this plate. They've been marked out accurately, and this thing here is called a wiggler, and I'll show you how that's adjusted. We'll have to start him up, and we use this thing here. Now that is showing precisely the axis of that spindle, and if we use these controls to move that part directly over that, where that hole is, where that mark is, there it is. Now I use a loop to get that in the right place, make sure it's perfectly correct. There we are, there, a little bit more this way. You can get within about 5/1000ths of an inch by using this technique. That's it, that's right. Now that's bang on. Off we go with the fairly high speed for this little tiny centre drill. Now just have a look at that hole and see what that looks like. And see whether that's correct. That looks pretty good. In fact, I'm not too happy with that dimension, so I'm going to move it over a little bit. There you control, because I cut out to 5/8 exactly. I'll show you how we do the other one. We can, hopefully this will be, we can move this over to the other one here. And check him, see what he looks like. Put this on, and there we go. And where's my little magnifier? There we go. That's pretty good. That's pretty good. Okay, now we can put a centre drill in. Turn that off. This is only put finger tight in here, it doesn't need to be tight. And there's our little centre drill. There it is. And again, fast speed. Perfect. Now we put a bigger drill in. This is just a quick way to get to a size where we can put the boring head in. This is a 1/2 inch end mill, and it's been pretty straightforward. Now we change over to the boring head, and now that has been set for the other hole I just made. So here we go, and hopefully we'll get the right size hole out of this. With a very fine cut. Slow feed. We should stop. There we go. That's just right. Let's check it with a plug gauge. There's a 5/8 diameter thing, and it's perfect. That's that. I'm going to drill the holes for the bearing housing mounting. I'm using the wiggler again. I'll just go through this again because this is rather important to get this right. So we turn the old wiggler on, turn the milling machine on here. There it is, and as you can see it's pretty well lined up, and I'm just going to put some drills in. Now we're using a number 50 drill, which is a tapping size for these bolts when they go in. Straightforward drilling operation. Now we move to the other position, and that's 7/8 of an inch. In other words, it's 14 turns on this. I just checked it with a wiggler and it's spot on to the mark where we marked it accurately before. Center drill again, same deal. And again a straightforward drilling operation. Except we need a bit more speed. That's the beauty of this machine, it's infinitely variable up to about 2500 revs. Excellent. 15 turns, and that should be lined up. Simple matter to assemble these bearing housings on the bed plate with the crankshaft in place, and then we can drill and get those things bolted in place. Again, we use the wiggler and get that thing lined up exactly, and then we're going to go 14 turns on the dial down here, and it'll be 7/8, which should be the other hole on the other side. Right. There we are, 14 turns, bang on. So off we go again. What to do now is tap those holes 256 for the bolts and open those holes up in the housings for the clearance. Here's a little gimmick which is very useful. This can be done when tapping holes. This thing is about the most useful thing I've ever bought from Canadian Tire. It has a centre in it, and what you need when I'm taking this out now, I've already tapped that hole, but it needs some preload in it, you see. This thing here is a little preloaded. All it is a little piece which has got a spring behind it, and that pushes down. Doesn't have to be tight in the chuck, just have to be loose enough that it'll slide up and down, so we can put some preload on the thing. And that is something that's very useful indeed. Here's this little devil so you can see it properly. This is all it is. It's a bit of 1/2 inch stuff with a spring inside it. Just poke that up in there. Just make it so that it slides up and down easily, but doesn't fall out. That's it. That's good enough. Push that up in place. I've got this thing already lined up. Put the tap in the hole. A bit of preload on, and there we go. How about that? This is a quick way of doing the same thing. You know, we can use that little centre we've made, and there it is, lined up pretty well with the centre. We don't have to use the wiggler all the time. Now here's a variation. Rather than using that tap wrench, here's a pin vise, and that pin vise has a hole in the back of it there that fits into this taper, so we can put that in there. And the only thing is, this bloody thing's a bit long. Whether it will fit or not, I don't know. Really pushing it. Yep, that'll do. See, a very small hole like a 256, you can do it with your fingers, so that saves a bit of time. It has been designed for my Iona Thames River paddle tug, and as a development of my previous designs, key features of this engine are the twin cylinders, double acting for self-starting, which is essential for an RC model. This has piston valve, which are simpler than slide valves to build. It only has 2 ball bearings on the crankshaft main bearings. It has no lower cylinder heads, and the reversing valve exchanges inlet and exhaust, simplifying the valve mechanism. The components basically are, here is the crankshaft, which is 1/4 inch diameter unhardened 01 high carbon tool steel. The bearings are, here are the bearings, and these are standard R4 seal bearings, and the crank webs mild steel. This is the same material as the crankshaft, this hardened, unhardened tool steel. And the bed plate is, and these bearing housings are aluminum. And the cylinders will be made of, we're going to do a very interesting part of the job, and that is setting up the crankshaft. Now these crank webs have got to be exactly 90 degrees apart. Now how we do that, they've been made exactly the same dimensions vertically and horizontally, so that they can be stacked up on these blocks. And what we do, we use this stuff, Loctite 620, to basically get them in the right position. So we'll do that by starting off with this part of these 2 webs. These are 2 individual pieces which get put together first, and then we put them on the shaft. We just put a little bit of this stuff on here. I've had this for some time, this stuff. I don't know if it's all going to come out. Yeah, put a little bit on there. This apparently needs no oxygen for it to cure. So we put them in there, make sure it's all in, all around there. This one too. Might as well put some inside there. Make sure it's all, just wipe it off when we don't need the bit we don't need. There we are, that's all together now. Now to space them apart, the correct distance apart, what we do is we made these little bushes. Now we've got to wipe that thing away before we do that. There we go, that's squeezed together now. That bearing spacing them between it, and that is not on there yet. This is going to be a later job. There's no glue in there, but there is glue in here. Now this is only temporary until we get it all lined up, and then we'll drill and pin it. Some people don't do that, but I don't trust this stuff all that much. Here's the other one. Difficult to hold this and show at the same time, but I'm going to put this in here like this time. That's one side. That's the other side. Okay. Slip that on the shaft. Now if it does get stuck inadvertently, we can always undo it by sticking it in the oven at 350 degrees. Apparently, never had to do that, but hopefully we don't have to do that. So these are the 2 halves of the little. I'm just going to use 1 half. I think that'll be just fine. Okay, that's it. Now we leave that there for half an hour. Let's see what the hell happens after half an hour. Well, success with the this part, and then we'll put some glue on this one, and that'll be that job done. Same on the other side. Make sure there's plenty of glue on here. That's that. And all we're going to do is set the other one up 90 degrees to it. There we go. Job done. Well, success. Everything's just worked out just great. All we've got to do now, we've got to leave 24 hours for that stuff to really set up, and then we can drill and pin those webs, and then we can cut the piece of crankshaft away that's got to be taken out. For drilling and pinning the crankshaft, first thing we have to do is to put it in the vise and make sure it's level. And how we do that, we can get one of these and put it on there, like that, and then we can just get this little cheap little level, which works beautifully, and just put him on top. And there he is, and that's pretty good. And we pick up that hole and do the deal with the wiggler and the number 55 drill I think I've used, and then the 16th reamer for those holes, and I've got to do that with all 8 of them. Now we've got it all riveted up, and it's and all ready to go, and we can just cut this. We're cutting this away in the crankshaft away to finish it off. The machine, the cylinder, this is a piece of 1-inch brass bar set up in the 3-jaw chuck. And I'm using a finishing rounded tool bit in the tool holder. And here's the drawing. I always make a drawing of these things before I do them. You find out all kinds of things you hadn't thought about if you make a drawing. So the first thing we do is face it off to length, and this is checking the length here on this digital caliper. And that says 1.465, so that means it's got to be 1/4, that's 15 thousandths to come off. So we can set this little slide here to compound slide to 15 thousandths. There it is there. There we go. That's it. Now I'm replacing that tool with the facing tool. And that's just check that for sharpness, and stone it up with this little diamond stone, and put that in the thing here and tighten it up. This is a really great rig, this quick change tool post. This is a turning and facing tool. It's set up so that you can do both of those operations in one go. And I've set that up on the compound slide so it takes it off to the right depth, right length. Now we check the diameter here, see how we're doing. And what have we got? 0.668. So we've got to figure out what we've got to go down to 625. So see, that looks about right. Let's take them off and we can have a look and see what it fits snug onto that plate. Well, there we go. That's the first phase of that machining. That cylinder now on the 5/8 diameter and a 5/8 collet. Now that keeps everything absolutely lined up, and it's all ready to be drilled. And we're doing a bit of drilling now. This is about a 7/16 drill. We're going to open it up to just under 1/2 inch, and then we're going to ream it. Now we've got it set up for the reaming the hole, and this is known as a chucking reamer, And one of the advantages of this old lathe is that you can pull it over by hand. This belt drive allows you to, the whole thing about reaming it's got to be done quite slowly and very sensitively on the feed. Shows a very simple parting off operation on the cylinder head. That's a straightforward, simple turning and that kind of operation. Now I'm machining the spacer that goes between the valve housing and the cylinder. Another interesting machining operation. This has to be a 5/8 cutter on one side and a 7/16 on the other, and they've got to be completely lined up properly. And we'll see how it goes. Just getting ready to drill the valve housing tubing here. It's a 9/32 hole. It's going to be reamed, but first of all I've got to drill that hole. Now, drilling brass, you've got to be very careful with it because it snatches and the drill will jam and it's a damn nuisance. Now what you have to watch out for is the angle that drill is cut at. If you look at this drill, this is a much steeper angle, and that one is liable to grab. So I've chosen the one with the longer spiral on it. I drilled that with a drill which is about 5/1000ths under the 9/32 reamer, and this is known as a chucking reamer. It goes in the chuck like that, and it's completely parallel. It doesn't have any taper at the end of it. So that's what I'm using, and gives you a very good fit. For drilling the steam ports in the cylinders, and these ports are 0.78 diameter, and they're put in with a little milling cutter. But first of all we have to locate them accurately, and we do that with the wiggler. We've seen the wiggler working before, and here we go. Here it is. And bring that down. There it is, and that's it between the flanges and the cylindrical part of the cylinder, and that is lined up accurately, and we're ready now to put the ports in. And this 30-degree angle is marked with this thing here. It's a new Japanese gadget. You stick it on here and push the button, and there it is, 31.8 degrees. That's close enough for 30.5 degrees. Close enough for what we want. Here we go with the cutter, and pretty fast speed. Now I'm drilling the inlet and exhaust holes in the valve chamber. This has been all lined up and accurately put into place. The centre drill. Now all we have to do now is move this exactly a ½ inch, which is 8 turns on this thing. 1, 2, 3, and so forth. Each turn on this handle is exactly a 1/16 of an inch, so 8 turns is ½ inch. So that's how I measured those ports. Solder this thing up with all of the valve arrangements on it. We're going to have to drill the holes for the cylinder head mounting and the cylinder mounting onto the frame. So we're doing this in a thing here called a dividing head, and there it is. There, it's all set up with the thing, and I'm putting 4 holes in, and they're all. This thing turns any angle you want. There's the angle thing there, and that thing is set up so it's all, each one is exactly 90 degrees to each other. This little jig we just made, we can drill the holes for the cylinder mounting. It fits on there, that's 5/8, and it also fits on here. This is a 5/8 thing, just have to get them lined up, and it'll also be used for, I have to make a little space of that for the cylinder heads, so that will be used for those too. Job's done. The holes into the mounting plate using the wiggler, and there's my little spyglass, and there's the drill. Now we drilled all the holes for these cylinder attachment thing, and we've got this thing all ready to do the tapping, and this is rather a pleasant job because everything's all absolutely accurate. And here we go, we just tap that thing with a this is a regular pin vise, and that's a very easy job. Now I'm drilling the holes for the cylinder head bolts, and I made a little fixture here on the this thing here that we talked about yesterday, the dividing head, and that's all set up now, so we can get all those holes drilled. We're now moving on to the connecting rod. This is the big end part of the connecting rod, made of bronze. There's one that's finished, and this one's being made. There's two of them, of course, and they're just being drilled for the bolts, which are 172 bolts, and we use the wiggler and the center drill just like we did before. Notice that they are held in a toolmaker's vise inside the milling vise in the machine. That gives the possibility for another way of holding it. And that's another use for this vise, again marking the cut mark for this this big end piece has just been marked off 7/32 deep, and I'm going to cut that now with a saw. Here we go with the cutter. It's a I think it's about a 32nd or an inch thick, that cutter we gave it. It's a 7/32 drill, that's what we want, 7/32. So it's a little bit more than that, so just be safe and cut it that amount. Here we are, milling it down to final size. There's 9/32 cutter, very high speed. Okay. Now we're tapping these holes in the this is the other part of the big end. Now we're just tapping this up with the 172 hole. These are very nice to tap this with this bronze because it doesn't clog, and it really does a kind of an interesting job. So there we go with that. And this is the other piece, and we're just going to open those holes up for clearance for the bolts. Now I'm making a small end exactly like this one for the other connecting rod. And I've got it set up here in the rotary table in a horizontal position, and then I can turn this to 360 degrees, of course. As a final operation, the wrist pin hole 9/64 is being reamed, and that's the final operation on this small end. Connecting rods have been put on the crankshaft, and they've been fitted fairly well. They're not quite right yet, but it's good enough for that, for this stage. Now here's another little aspect of this thing that's changed a bit. I was working on this arrangement here, which I showed you earlier on, the valve casing and the relation of that with the cylinder. And this was these things go like this together, like that, And this little piece here, those are the ports which we milled in there, and this is a spacer which is fitted in there, and I was having trouble with locating all this. I should have made a jig. Anyway, I got fed up with the whole thing, I took it all to pieces, and now I started a completely new design, which is, this is the valve housing now. That's the hole being drilled there for the drill and ream for the valve, and this now directly fits onto here, and that's just a straightforward soldering job with no problem at all. So that's what I'm doing now. This is kind of a bit of an interesting job because of that long ream. And now one of the features of this, of course, is that I have to machine this housing now to fit the cylinder. And this is the other one. There's two of them, of course. And this fella is in the vise, and there's a 5/8 diameter cutter which is lined up, and that's ready to cut that peculiar sort of slot there. Let's start up the thing and see what happens. And that's with a very small cut each side, so it doesn't move. There it goes. And that has to go until it's exactly the right width. Here we go with the cutter set. I'm only taking a 5/1000 at a time. It really does quite a nice job, actually. It has to be lined up perfectly on line and perfectly parallel with the cylinder. Just keep doing that until I've got the right dimension. Now we're milling the valve ports. That's a 332 suck cutter, and I just read the book, and you can run that as fast as this machine will go. There we go. And I got the stop set to the right depth, and I just do that 3 times, and that's the way to get those done. The valve chamber to the cylinder now, and now we're ready to lap the cylinder. And this thing here is called a barrel lap, and how it works is that it's got this tapered screw in it, and you push that in there. This has been split, so we squeeze that in there and that expands, and when we put this stuff on, this is the diamond paste, and we put that on there. This goes in and gets adjusted to whatever it is we need, and we just put that in there, on there, and this has already been lapped. You just go backwards and forwards like this slowly, and adjust the speeds, and after a bit you take it out and wash all that stuff out, which is very tedious, but eventually it'll make it parallel and accurate to what we need for the piston fit. Now we lap the piston. The piston has been made out of bronze. It's a very simple little thing, but it's very, very careful to make it absolutely concentric with the bore, which is a very small bore. It's 5/64 of an inch, and it's been done on this spindle, this piston rod, and this is just the same as running with the going with the cylinder. I'll just start it up, just keep it moving, and this has got that same red stuff on it that the cylinder had. Let's see what that looks like. This is the lap. It's just a piece of brass. That's bronze, and this is brass. It's been cut out so it can be squeezed, and that gives us a diametral fit we need. Now I'm making what I call the lower cylinder head. These pieces have already been turned to fit the cylinders, and they've been reamed to fit the piston rod. Now I have to cut them off to length. Now here's a little trick that I've learned over the years, and rather than measuring that, what I do is I bring that parking tool exactly to the edge of the piece, and I set the compound slide over here to 0, and then I turn that 4 turns, 7/16 of an inch, so that's 4 turns plus 37 thousandths, and that's the parting off and parted off. That's it. I'm now making the fittings for the piston rod, which fits into the small end of the connecting rod. This has got a number 172 hole in it, and this is set up in the lathe. There's a pin vise holding the little 172 tap, and that's being, I've modified my pin vise to accept that tapered thing there with that spring-loaded gadget which fits into the big chuck, so that can handle some small stuff. To explain that a little further, this has been fitted, been drilled out and counterbored out or countersunk out, and this is a spring-loaded gadget, and that just sits in that big chuck there. Now we've got it in the mill in this little milling square fixture I've got. This is in a little small collet. That's the and it's just a simple matter to turn it over, mill one side, turn it over, and mill the 4 sides of a flat. Works very well. Well, we milled that thing rectangular, and now all we've got to do is put the hole in it. That's it. Now I've made the fittings now that go on the end of the piston rod and connect with the small end part of the connecting rod, and now I'm milling the radius on these, which is something you'll never find in a book. How you do this. That is set up so that it's absolutely square to the thing. I just keep going until the complete radius is formed. Now here is the assembly. This is this little piece that's just been done, and this is what they call the lower cylinder head, the piston rod and the piston assembled, and that's ready to go into the cylinder, and that'll be the end of that little job. Coming up to the final operations now. The cylinders have got pistons and piston rods in them, and they've been checked out for clearance and everything, and now all we have to do is to drill the ports, and we're setting this up with the wiggler to put the exhaust ports in the valve passages. So we still have the valves to put in, but we are doing a little bit of running in to free everything up, makes it a little bit easier to move stuff around. So a little bit slow speed in the lathe for a little bit of time, and then we'll be working on the valve gear. The little fitting here for the valve rod, this is these are 5/32 square, and this is the device I'm using here, this little thing we've seen before, and it's just going to do the last cut down there to make it square, and then we're going to put the holes in and mill the slot. The valve themselves have another lapping job. I used the old housing that I never used, and I used it as a lap. Now these have been lapped in here, and they're within about a couple of tenths of a thousandths, I suppose. It's got to be very accurate, and they just slide in there very nicely and get attached. And there it is. It's made of aluminum, and quite a challenge. Now we come to finish off this little piece and put that radius on the end of it. We use this rig rather than use the big mill. I got this little mill here, which is the old Unimat, and the motor conked out on this thing. So what have I got on there? I've got a good old Dremel thing on there, 100 watts. Just gear it down a bit. This is a setup as I've just turned a pin in the vise, which is the 0.72 diameter hole, and that thing pivots around there, and that's a 1/8 diameter Dremel cutter in the middle there. And I just go around 180 degrees, and make sure it's over there, then put a bit more feed on. Couldn't do that, that's a fine cut which is not good. Anyway, look at that done. And there's the finished piece ready to go into the connecting onto the valve stem. A little bit of running in now, and we're almost ready to start it up. The valves have been fitted and the timing done. Very tedious to get that right, but I spent all afternoon putting that together. Quite a slow speed on the lathe. It run this probably for half an hour or so. I have run it before we got to this stage, but now all the cams and everything else is in, so we just put a little bit of this stuff in there, and that's what we got. We've got it all. I've done the inlet and exhaust manifolds, and I got it rigged up with this reversing valve. This is a reversing which will be worked by a regular servo in the boat. That's full of head and that's full of stern. And this is see if it rewards us with a start. There we go. Now that's running at probably a bit too fast, so I'm probably going to have to put a gearing in it so I can slow it down a bit. But anyway, that's one direction, and this is the other one. Not quite. It's got to be exactly right there on the thing. Until I get it really rigged up, and then I'll be able to slow this down by moving the valve just a little bit. Do that on the transmitter, on the radio control. So I can check the speed, of course, for the rev counter before I put it together. But anyway, that's about 10 degrees either side of the position will give us full speed in the middle. So there we are. I've had to do quite a bit of running in with it. And this little job here is fine. It's getting a bit hot, but I can put your hand on it. That 12-volt battery I think will run for about 20 minutes at least anyway. So there we are, that's the end.